Everybody. In this video, we're going to talk about two-dimensional measurement. And this is kind of an extension of what we talked about last week, because in last week's video, we talked about the principles of measurement and some of the misconceptions that happen when you're measuring length, which is a one-dimensional measurement. And in this unit, we're going to talk about how to make two-dimensional measurements. So we kind of started this last week when we talked about how there's two-dimensional units, like the square units that we use to measure area. But in this week, we're going to dive deeper into that concept. So for your case studies this week, you guys are going to see more examples of one-dimensional versus two-dimensional measurements. You're going to see how you can make two-dimensional measurements of three-dimensional objects, and how you can develop the formula for the area of a triangle instead of just giving the students the formula for the area of a triangle. So those are some of the themes that you'll see in your case studies. And for your video projects, you guys are going to describe how to find the area of a trapezoid, circle, or parallelogram in a conceptual way instead of just saying, here's the formula, plug the numbers in. So you'll be doing that for your video projects. And then some of you will be doing surface area, which is a two-dimensional measure of three-dimensional objects. So those are the topics for your video projects. For your homework, you'll do some activities that compare perimeter versus area. You'll also be finding the area of some composite two-dimensional shapes where you have to kind of break down the shape into like parts so that you can find the area of each part and then add them together. And then you'll also be finding nets and surface areas of three-dimensional shapes. So as a review of what we learned last week, when you're measuring length measurements, those are one-dimensional measurements. And an example of a calculation that's often done is to find the perimeter of a two-dimensional shape, which is essentially the length of a line that goes all the way around the outside or the boundary of that two-dimensional shape. Then there's two-dimensional measurements, which are basically measuring like how many square inches or square feet or square miles fit within that two-dimensional shape. Or there's the three-dimensional measurements of volume that we'll explore next week. So the first type of two-dimensional measurement that's often found is just the area of a rectangle. So one way you can teach the area of a rectangle is to tell your students, when you're finding the area of a rectangle that is, let's say, 5 inches by 4 inches, you just multiply the length times the width, and that's the area. That would be one way of teaching the area of a rectangle. But it's not really giving the students an experiential understanding of the concept of what area really means. And so a better way to teach the area of a rectangle would be to give the students a rectangle on, like, say, a piece of paper and ask them to describe how much space is inside of the rectangle and just see what they come up with. And they might get lots of different ideas, and the case studies that you guys will read will show some of the different concepts that students may come up with. And eventually it will become pretty apparent that you need a way of defining what the units are to measure the space. And so at this point, you could introduce maybe some graph paper, or even like, I know there's like little plastic squares that you can use that are like 1 inch by 1 inch. I don't remember what they're called, but they're a type of manipulative where you just have like flat plastic squares. And you could say, okay, well, what if we use these as our measurement tool? How many squares are within this rectangle? And once you give them that manipulative, that will really kickstart the process of discovering area, because they'll arrange all of these squares, and some of them might have overlapping squares. Some of them may have spaces, so you can kind of review those principles of measurement that we talked about last week. But once they correct those misconceptions, they'll be able to see that there's 20 square inches. And you can use this as an opportunity to help them differentiate between one-dimensional measurements and two-dimensional measurements. Because an inch is kind of like a tape measure type inch, or like the length of a string that's 1 inch long. versus a square inch is like those little plastic tiles. And so it's quite different whether you're talking about 1 inch or square inches, but there also is the connection that a square inch is 1 inch on both sides. So that would be a really good way of introducing the concept of the area of a rectangle. And then you can, like, once they've played with that, then you can give them a different rectangle and ask them if they can predict the number of squares that will be in that rectangle based on what they had just explored. And as they look for those patterns, they might intuitively figure out for themselves that the way that you find out how many squares there are is you just multiply the length of the rectangle by the width of the rectangle. So that's kind of the way that I would introduce the area of a rectangle if I were teaching it to my students. Because it's always best if you give them an experiential experience with the shapes before you introduce the formulas of the exact procedure that you go through. Because if you allow them to experience the shape and discover their own patterns, it will help them remember it better and really understand the shape on a deeper level. So that's an example of how you could find the area of a rectangle. And in the case studies, you're also going to read about how to find the area of a triangle. And this also showed up in the article that we read during week 1, The Mathematician's Lament, because he actually used the process of finding the area of a triangle as an example of how math can be seen as an art. Because rather than just memorizing the formula that the area is 1/2 times the base times the height, you can actually build intuitive understanding by saying, okay, well, if I drew a rectangle around the triangle, the area of that rectangle would be the base times the height because of the exploration that hopefully they would have done when they found the area of a rectangle. So hopefully that part makes sense. And so that part is basically finding the area of the rectangle. And then the triangle, if you look at this piece, this triangle takes up half of this part of the rectangle. And this part of the triangle takes up half of this part of the rectangle. And so that means that the area of a triangle is 1/2 of whatever the area of the rectangle is. And if you lead the students to discover this formula for themselves, they're going to have a much deeper understanding of the area of a triangle than if you were to just tell them what the formula is. So on your guys' homework this week, some of you guys for your video project will be describing why the formulas for the area of a parallelogram or the area of a trapezoid or the area of a circle are the ways that they are. So the area of a circle one, just so you know, is actually not an elementary school topic. It's a middle school topic. But the reason why I'm including it in this course is because if you can conceptually understand why the area of a circle formula is the way that it is, it will give you a deeper understanding of how area works and how to derive those formulas. And that will prepare you to be a better teacher when you're teaching more simple concepts like the area of a rectangle or the area of a triangle. So that's the reason why your video projects are on middle school topics, I guess you could say, is because if you can understand where the students will be going after your classes, that will help you teach the simpler concepts in your classes that are meant to be a foundation for what they will be learning in middle school. So that's the basic idea of how to help students derive the formulas for the different area formulas. Another concept that's also important, and we talked about this a little bit in the first week, is the idea of decomposing area. So this is a two-dimensional shape, but it's kind of a weird two-dimensional shape. And you don't really have a formula for the area of a decagon that specifically has these side lengths. Like that would be inefficient to come up with formulas for all of the different possible shapes that you could have with the various areas. So when you have a shape like this, the key concept that students need to understand is that they can decompose this two-dimensional shape into simpler two-dimensional shapes that they do know how to find the area of. Um, because you could find the area of this by just counting up all the squares because it was very conveniently drawn on graph paper, or you could split it up into these rectangles and use the formula that they discovered for the area of a rectangle to find each of the areas and then add them all together. And that would be a more efficient and faster way to find the area of a two-dimensional shape like this. So on your homework, you guys are going to have some area problems where you find the area of composite shapes. And some of those shapes involve circles. Like there's one problem on your homework that looks, or the shape looks kind of like this. And you have the various measurements. And so the key on this one is to decompose this as a rectangle and then a half of a circle. And you find the area of the rectangle and then also the area of the half of a circle. And then you add those two areas together. So you'll have some problems on your homework to help you practice that. And another concept that will show up on your homework is the concept of surface area. So surface area is a two-dimensional measurement of three-dimensional space. So in our first video, we talked about how cross sections are two-dimensional components of three-dimensional objects, because you can like cut a cylinder right here and you can get a two-dimensional circle as the surface of that cut. And surface area is another way that you can decompose three-dimensional shapes into two-dimensional shapes. Because the idea of surface area is you figure out how much area is on the surface of the three-dimensional shape. And one of the easiest ways to help students understand this is to first have them understand what all the surfaces are. So like on a cube, you have 6 surfaces because you have your top, then you also have the bottom, which you can't really see on this picture. Then you have the front face and the back face, and then you have the 2 side faces as well. And so essentially you have 6 different surfaces, and to find the two-dimensional surface area, you need to find the area of all of those two-dimensional surfaces and then add them all together. And one way that it can be helpful for students to visualize this process is the concept of nets. So a net is basically a two-dimensional representation of the three-dimensional object. So one way I like to think about it is if I were to take a three-dimensional object and cut along all of its edges or some of its edges and unfold it, that would create my net. So this is a good picture of it because this blue rectangle that's on the bottom of my three-dimensional prism is represented by this rectangle right here. And then when you unfold these 2 sides of the prism, you get those rectangles. When you unfold the front and the back of the prism, you get these. And then this is the top of the prism. So a net is basically if you were to unfold this three-dimensional object and make it like a flat piece of paper. And there's lots of really cool activities you can do with your students to help them understand this concept. If you just Google like nets of polygons or something like that, there's a lot of worksheets where the students can actually cut out a net out of paper and then fold it up to see what type of three-dimensional object it creates. And those types of activities are really good because it gives them like a hands-on experience with that process of unfolding a three-dimensional shape to make the net. And when I have taught middle school, I usually teach them this concept of nets. But one other way that also helps is just to make a list of all of the surfaces. Because sometimes it's a little bit harder for students to visualize the process of unfolding the shape. But if they just make a list of all the surfaces, it can help them find the surface area in the same way. So like, for example, they might say, oh, well, I know that there's a rectangle that is 7 by 9, and that's the bottom. And they might even label this, that this one is the bottom. And then the top is the exact same rectangle of 7 and 9, and it would have the same area. And then they can say there's the front, there's the back, there's the side, and maybe they'll specify left side versus right side. And then they can draw all the different rectangles that are represented by those. And that can also help them transfer these measurements to the measurements on a two-dimensional figure. So that's another strategy that can also help if your students are really struggling with the idea of nets, that can help them break it down into smaller pieces. And then you can move to nets from there. Because oftentimes it's easy for them to identify the different faces, but it may not be as easy to think about how those faces connect to each other when they're creating a net. So here's some examples of what nets of various 3D shapes look like. And you can see they're kind of interesting. Like the net for a cone is essentially the circle that's on the bottom of the cone. And then you also have this kind of like pie-shaped partial circle that makes the sides of the cone. So one of the extra credit assignments, or not extra credit, but one of the more challenging videos that you can choose to make this week if you would like, is you can describe why the surface area of a cone is the way that it is. And any of you are welcome to do that if you would like more of a challenge this week. So it won't be one of the assigned ones, but if you want to change your video topic and do the surface area of a cone instead of your assigned topic, you're totally welcome to do that. And thinking about the net as a circle and then a part of a circle is a good way to start deriving the formula for the surface area of a cone. So that's it for this lesson. I hope that this was helpful for you. And just like with all of the topics we've talked about so far, when you're teaching these concepts to your students, please make sure that you give them an experiential experience with it rather than just telling them the formula. And there's many different ways you can do this, lots of different types of word problems or real life applications that you can use to help them really internalize the concepts of area and other two-dimensional measurements instead of just memorizing the formulas. So I hope this was helpful for you. And if you have any questions, let me know.